Hi, I am Miss Janice. Today we are going to learn about the way to solve a Bernoulli equations. Previous lesson, we have talked about substitution method. When we have a homogeneous equation, we can use substitution method to solve it. What is homogeneous equation? Let's recall. Homogeneous equation is actually a differential equation where dy over dx is a function in terms of y by x, which means it is a function in terms of v, where v equals to y by x, or normally we say that y equals to vx. We prefer a product than a quotient. For homogeneous equation, to solve it, we use substitution method by substituting y equals to vx. Now, what about Bernoulli equations? First of all, what is a Bernoulli equation? How does it look like? And how do we solve it? Yes, we should use substitution method to solve it, but what substitution should we use? Let's see. A first-order differential equation of the form dy over dx plus pxy equals to qxy power of n. So without y power of n, it is actually a linear first-order differential equation. But if we have on the right-hand side qx times y to the power of n, then this is called a Bernoulli equation. So if n equals to 0 or n equals to 1, then this differential equation is linear, and we can integrate using integrating factor method. This means linear first-order differential equation method. LFODE, alright? Because in LFODE, to solve it, we first find rho, right? Which is e to the power of integrate px dx. So this is called integrating factor. However, other than n equals to 0 or n equals to 1, we should use substitution method by substituting v equals to y to the power of 1 minus n, where n is from here. Take note on this. It's a standard procedure. So before I move on with examples, let's talk about when n equals to 0 and when n equals to 1. How come it's linear and how come we need to use LFODE method? So talk about n equals to 0 first. dy over dx plus pxy will be equivalent to qxy to the power of 0, right? Which is 1. So you see, this is exactly a linear first-order differential equation. So we need to use the rho to help us to solve the differential equation. What if when n equals to 1? dy over dx plus pxy will be equals to qxy to the power of 1. This differential equation is actually a separable variable dE. How come? You see, this is y term, this is also y term. We can group them together, bring pxy to the right hand side, and factorize y. We have y times qx minus px. See, is it separable? It's a product of y function and x function. So this is a separable variable dE. We can group y term with dy and x term with dx to solve this differential equation. So from now on, when you have a differential equation in this form, if n equals to 0, it is linear first-order differential equation. If n equals to 1, it is a separable differential equation. Now, let's see the examples on Bernoulli equation. Example 8 in the notes. Writing the homogeneous equation in example 7 as a Bernoulli equation, then solve it. So this is the equation from example 7, question 1. So we follow the steps. We need to write it as a Bernoulli equation first, and then we need to solve it. So from here, I divided by 2xy in order to make the coefficient of dy over dx 1. So we have dy over dx equals to 4x squared over 2xy plus 3y squared over 2xy. Move on, we get 2x over y plus 3 over 2 y over x. Group the y term to the left So this is y term, bring to the left, minus 3 over 2x times y equals to 2x y to the power of negative 1. See, this is Bernoulli equation. Bernoulli equation, because it is in the form of dy over dx plus pxy equals to qxy to the power of n, where comparing n is actually negative 1. So to solve a Bernoulli equation, we need to use substitution method, letting v equals to y to the power of 1 minus n. Please make sure you remember this. What is n value here? Negative 1. We sub in. So we need to let v equals to y squared, because 1 minus negative 1, 1 plus 1 is 2. Next, what to do? If you remember about the substitution method, we first need to differentiate this with respect to x implicitly. Then we write dy over dx, the subject. dy over dx will then be 1 over 2y dv over dx. So keep this as 1. Then from the Bernoulli equation, we need to convert it to v and x term. First, we copy the Bernoulli equations. Then we substitute the first one into the Bernoulli equation. From 1, so you sub in dy over dx is 1 by 2y dv over dx minus 3 over 2xy equals to 2xy power of negative 1. It is a mixture of y, x, and v terms. We need to simplify it to v and x only. So again, do the similar things. I will prefer the first derivative alone. I want to get rid of 1 by 2y. So for the whole dE, I multiply with 2y. Then we get dv over dx minus 6y squared over 2x equals to 4x. If you do this correctly, you will notice the y term will always be converted to v. See, this is y squared. What is y squared from the substitution? It is v. Therefore, we move on. dv over dx minus 3 over x v will be equivalent to 4x. So check the type of the differential equation here. It is FODE. Most of the time, when you have a Bernoulli equation for a differential equation, when you use the correct substitution and continue with the simplification to v and x term, you will get a linear first order differential equation. Let's continue solving it by using our FODE method. We continue in the next page. The FODE is dv over dx minus 3 by xv equals to 4x. Let's check it. Yes. So step 1, find rho, which is e to the power of integrate px dx. That is equals to x to the power of negative 3. Step 2, write it clearly. Multiply rho, integrate with respect to x, both sides. So we get x to the power of negative 3 dv over dx minus 3 by x to the power of negative 3v. Integrate with respect to x. This is left hand side. For the right hand side, for x power of negative 2. Integrate with respect to x. In step 3, we know that left hand side will always be rho v equals to integrate this. We get 4x power of negative 1 negative plus c. Move on, write v the subject. V will be negative 4x squared plus cx cubed. What is v initially? It is y squared equals to negative 4x squared plus cx cubed. We have got the solution. This is implicit form. So I hope you understand how do we solve a Bernoulli equation in differential equation. We first need to rearrange in Bernoulli equation form in order to get the n value so that we can substitute by using v equals to y to the power of 1 minus n. Start from the Bernoulli equation, substitute the differential of the substitution, dy over dx equals to 1 by 2y times dv over dx. Change it to v and x term. For Bernoulli equations, we know that it is always will be converted to a simpler differential equation, which is in LFODE. Then we solve it by using LFODE method. Let's see one more example. Number 2, solve this. First, let's divide this equation by x. We get dy over dx plus 6 over xy equals to 3y to the power of 4 by 3. So this is actually a Bernoulli equation. Dy over dx plus pxy equals to qx times y to the power of n, where n is 4 by 3, qx is actually 3, px is 6 by x here. So for Bernoulli equation, let's v equals to y to the power of 1 minus n, which means y to the power of 1 minus 4 by 3, negative 1 by 3. Let's differentiate with respect to x. dv over dx will be equals to, bring the power down, power minus 1, dy over dx. We need to differentiate implicitly. Write dy over dx the subject. This is dv. So dy over dx will be written as the subject. It is equals to negative 3 y power of 4 by 3 dv over dx. Substitute this into the Bernoulli equation. So we write down sub 1 into the Bernoulli equation. So copy the Bernoulli equation, dy over dx plus 6 by xy equals to 3y power of 4 by 3. Let's substitute dy over dx in, negative 3y power of 4 by 3 dv over dx plus 6 over xy equals to 3y power of 4 by 3. Then we try to make dv over dx alone. So for the whole differential equation, we divide by negative 3y to the power of 4 by 3 for all the terms here. So the first term will be dv over dx minus 2 over x y to the power of negative 1 over 3 equals to negative 1. Come to this stage, you will notice the y term will always be v. See, v is y to the power of negative 1 over 3. It's the same. Therefore, we will get a complete differential equation fully in terms of v and x. And it is LFODE. So let's continue to solve this differential equation. Let's continue in the next page. dv over dx minus 2 by xv equals to negative 1. For step 1, let's find rho, which is equals to e to the power of integrate negative 2 by x dx, that is x to the power of negative 2. For step 2, indicate clearly, multiply rho and integrate with respect to x, both sides. So for the LFODE, let's multiply rho integrate with respect to x equals to integrate negative x to the power of negative 2 dx. In step 3, left hand side, we will always get rho v equals to the right hand side. Let's integrate, we get x to the power of negative 1 plus c. Write v the subject. We will be having v equals to x plus cx squared. What is v initially? It is y to the power of negative 1 by 3 equals to x plus cx squared. This is the solution in implicit form. We can convert it to explicit equation, y equals to x plus cx squared power of negative 3. This is the solution for the Bernoulli equation. So here we have learned how to solve Bernoulli equation. First of all, Bernoulli equation must be an equation in the form of dy over dx plus pxy equals to qxy to the power of n. However, n cannot be 0, n cannot be 1. If n is 0, it is LFODE. If n is 1, it is a separable variable dE. Other than 0 and 1, it is a Bernoulli equation. To solve a Bernoulli equation, we need to use substitution method, letting v equals to y to the power of 1 minus n. Hope you understand. Thank you for watching.